Okay. Now we'll continue with the probability concept, right? So probability is that, see, how the probability means, the word probability comes from the probably. Okay. The concept of probability comes from probably. Probably means may, likely, happen or not happen. That we are not sure of the happening. Okay, we are not sure of the happening. So what happens? Probably means we are not sure, but it may be. So probability is nothing but measure of probability is measure of certainty or uncertainty. Because today it may rain, we can't say it will rain. It may rain. So there is a chance to rain or not to rain also. And tomorrow there will be earthquake. What is the guarantee that it will be earthquake tomorrow or it won't be there? So presuming, predicting the things and then expecting the outcome, okay, is called the probability. So now we are trying to measure the probability. Probability, the happening or unhappening, or certainty or uncertainty is trying to be measured, right, by the principle of probability. So I will tell you a very interesting story for you. There is a famous mathematician from Russia, Kolmogorov. Okay, he has a friend who used to be a gambler. You know what is a gambler? Those days, people used to go for casinos, bars, restaurants, and they used to play there's rummy, playing cards as well as the rolling or else dice like that. There will be different games. So every time you want to win, and you will ask that mathematician, Kolmogorov, famous mathematician, that which number I have to take so that I will win, and what are the chances that I should win? Because there is a probability, because there is a marble rolls, and after rotation the marble will stand at one place, that number will get the 100 times, and you will get 1 rupee ticket and 100 rupees will come. Similarly, lottery also, you will pay for 10 rupees and you will get 10 crores or 10 lakhs like that. So that's why what you can say, the probability of winning the game is to be found. That is asked by his friend. So Kolmogorov is a famous mathematician. Then what he had made a research. Then he took a coin, he tossed a coin. If you toss a coin, what happens? It can be flipped to get head or tail. If you roll a die, what can come on the face? Either 1 can come, 2 can come, 3 can come, 4 can come, 5 can come, and 6 also can come. Right? So the probability, now after the famous mathematician, the probability formula measure is equal to number of favorable outcomes by total number of possible outcomes. So now the probability is a number. Okay, probability is a number, right? Is a number or a fraction or a decimal. But what is the probability? It is a proper fraction. Say proper fraction, because favorable outcomes are always less than the total outcomes, because there is a test for you, 100 marks. How many marks you will get? Maximum 100 or less than 100. You won't get more than 100, na? So any time when you are taking a assessment or as a measure, the numerator will be less than or equal to the denominator. Always. Numerator will be less than or equal to denominator. It cannot be more than or equal to. So the probability is always a proper fraction or a decimal which is value is less than or equal to 1, or a fraction whose numerator is always less than or equal to the denominator, right? So probability is a number or fraction, decimal, where that is a proper fraction. Numerator is less than or equal to denominator. So probability of an event is equal to E is always lies between 0 and 1. It can be 0 also and it can be 1 also. Probability of happening an event. What is event we discuss? Okay. Happening is notated, is denoted as P of E. Probability of happening an event is denoted as P of E. Okay. So probability of an event is denoted as P of E, and it can happen to lie between 0 and 1. To lie between 0 and 1. Okay, 0 less than or equal to probability of an event less than or equal to 1. Okay, clear? So in this case, what happens? The probability is always a measure of certainty, and it lies between 0 and 1, and probability is always a value whose number is less than or equal to m. Have you noted this part? Have you noted? Yes, noted? Yes? Okay. Have you noted now? Okay. Now, see here, probability cannot be negative. This is important. Probability is never negative. Always it can be 0 or greater than 0. Probability it can be 0 or greater than or positive, but less than or equal to 1. Okay, probability lies between 0 and 1. Okay, probability lies between 0 and 1. Next, probability cannot be negative because you can't have negative values in probability. Not happening is cannot be negative, happening also cannot be negative. Not happening can be 0, happening can be 0, but not minus. Are you clear? So this is there. Now, example I take. If a coin is tossed, so the outcomes are listed as sample space. This is called sample space. Yes. So H and tail. This one is a sample space set of all outcomes is called the set of all outcomes of a random experiment. What is this random experiment? Let us see. Random experiment is taking or doing an experiment without having the idea of outcomes, and outcomes are uncertain and more than one. That is called the random experiment. Okay. Suppose I have taken a book and I closed my eyes and then I opened a book. Which number will come, page number? I don't know. That is called random experiment. From a what can I say bowl of 100 balls with different colors, I may take, by closing an eye, I may take a ball. Which ball will come? We don't know. Which color will come? We don't know. So this is called random experiment. Understood now? So random experiment is also called operation. Performing an operation whose outcome is uncertain and number of outcomes are more than one. So there is more than, number of outcomes are more than one, and outcomes is uncertain. Whose outcome is uncertain? We don't know. Okay, and done abruptly. It will be done without intimation. Okay, at a time. Okay, so that is nothing, not a compulsory. Then result is unknown and outcomes are more than one. That is called random experiment. Then what is event? Okay, event is taking one possible outcome. Event is denoted as E, happening of a thing out of a random experiment. Suppose example, if a coin is tossed, getting ahead is event. That I can say. Getting a tail is also, it can be E2, like that you can take, etc. Right? So if a coin is tossed, coin tossing is random experiment. Understood? This is random experiment. Okay? Then you are taking a thing in that. Getting a head or getting a tail is called the event. Are you clear? So event is part of the random experiment. Random experiment is a combination of one or more events. Are you clear? So random experiment is, event is a part of random experiment. Okay. There are more than, there are many events in a random experiment. There are many events in a random experiment. Okay, so this is getting a head, getting a tail, getting one head, one tail, no head, like that you can take. Are you clear? So like that you can take as many number of events as per our requirement. We can define as many number of events as per our requirement. Note. We can define as many number of events as per for a random experiment as per our requirement. Right? So E1, E2, E3, like that you can take. So event is a part of random experiment. Okay? Event as a whole. If you take more than one event, then you will get a random experiment. Are you clear? Yes, noted? Next. So, example, if a die is rolled, sample space is equal to set of all outcomes. What you get? 1, 2, 3, 4, 5, 6. Right or not? Sample space is that or enough? Die is rolled, you will get any phase of this. Now, getting probability of getting 1 is equal to number of outcomes favorable to 1 by total number of outcomes That is equal to how many number of outcomes favorable to one are there? One only. One out of 6. So n of s, number of outcomes, is equal to 6. Okay. Probability of tau s is equal to 1. 1 by 6 is the probability. Similarly, probability of 2 is also 1 by 6. 3 also 1 by 6. 4 also 1 by 6. 5 also 1 by 6. 6 also 1 by 6. Now what happened, you can understand. For all the events, we are taken getting probability of 1 is 1 by 6. All the events are having equally probability. So note, if all the events are having same or equal probability, then they are called equally likely events or equally probable events. Are having same or equal probability, then they are called equally likely events, or the probability of each event is equal. And if some of them you take P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5 plus P of 6 is equal to what I can say, 1 by 6 plus 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 1 by 6, that is equal to R sigma P of EI, that is equal to P of E1, P of E2, like that you can take. Sigma means adding only, I told you yesterday. P of E2 plus P of E3 plus P of E4 plus P of E5 plus P of E6, that is equal to 1. Sigma, always note, always sum of the events probability is 1. Okay, as total. Sum of the probability should be equal to 1. So they are called, if sum of the events is equal to 1, and all such events of an experiment are called the exhaustive events. Okay, so you understand what is equal likely? Okay, right? Exhaustive. Note, in a random experiment, if the sum of all events probability is 1, they are called exhaustive events. Okay, exhaustive events. Already equally likely probabilities are same, they are called exhaustive event, because there is nothing left, because every event is defined and the sum is equal to, becomes to be what you can say, total equal to 1. So the probability should not be more than 1, because the maximum probability of sum or independently any event is equal to what comes, 1. So the maximum value of a probability of the probability of an event should not exceed 1. It cannot be exceeded as 1. Okay, noted? Yes? Right. Next. Next. We'll see next concept, that is sure event or impossible event. Okay, we'll see what is this first by sure event. The probability of happening is must or sure, definite, then it is sure event. Okay, example, if a coin is tossed, getting either head or tail. So you took either head or tail means you want it can be either head or tail, not fixed one. So that's the probability. If a coin is tossed, it must be there, na? You should get either head or tail compulsory. So it's a sure event. So probability of head or tail is equal to 1 because number of favorable outcomes by total number of possible outcomes. That is the formula, right? For a probability. So favorable outcomes are how many are there? 2 by 2. That is equal to 1. So probability of getting head or tail is a sure event. Because it should happen. You cannot say that neither head falls nor tail falls. One should happen. Right? Such event is called the sure event. And the probability of sure event is how much? 1. So probability of sure event is equal to 1, which must be because favorable outcomes are equal to total possible outcomes. For a sure event, note. For a sure event, the favorable outcomes, the number of is always equal to number of total outcomes. Right? That is the sure event. Next. Are you understand what is sure event? Yes. Next, impossible event. Suppose similarly, if a die is rolled, getting any number 1 to from 1 to 6. Any number from 1 to 6 is possible, you will get definitely, and one of should follow the head. Okay. So again, that is also probability is equal to 1 to 6. Probability of getting 1 to 6 is equal to 1. So this surety is event. So sure event should have the favorable outcomes always equal to 1. Are you clear? Next, impossible event. By name only you understand. If the probability of happening of an event is impossible, an event is impossible or 0. It is impossible event. Okay. Now if a coin is tossed, getting neither head nor tail. You take the example. Neither head nor tail. None should come. How is it possible? Is it possible none should come? Definitely one will fall. You cannot say that I don't want head, I don't want tail. It is not possible. Then it is called, so probability of neither head nor tail is equal to number of favorable outcomes by total number of possible outcomes. Which is equal to favorable outcomes are how much? 0 by 2, which is equal to 0. So probability of impossible event is 0. Okay, now if a tiny road, example, one more example. Getting a number 0. So probability of 0, how much will come? 0 by 6, which is equal to, because 0 doesn't lie in the probables. In the outcomes of a die, 0 won't come. And if I get the probability of 7, number 7, again 0 by 6, which is equal to 0. Probability of getting 7 is also 0, probability of getting 0 is also 0, because 7 won't come in the faces of a die, 0 also won't come in the faces of a die. Are you clear? Yes? Clear? So this is called impossible event, and here also getting neither head nor tail is also impossible event. So probability of impossible event is 0 and probability of sure event is 1. And probability of equally likely events is lies between 0 and 1. Yes, noted? Now we can see here. So we can find out now this one. So we can write a note. 0 less than probability of an event less than or equal to 1. This is impossible event. Probability of, this is probability of sure event, and this is probability of equally likely event. So equally likely event lies between 0 and 1. This is also called as unbiased. For an unbiased experiment. What do you mean by unbiased experiment? Suppose I artificially made a coin whose both sides are head on it. That is biased, because naturally what should be there for a coin? It should be one side head, one side tail. But if I made willingly both sides head, suppose if I toss a coin, head only will come up, both sides head means I manage like this, then what happens to that coin? That is called unbiased experiment. But actually what you have to do, unbiased means without favor, without any advantage, without any favor. That is what always we go with the unbiased random experiment. We never go with bias. We cannot think of the coin whose two sides are head, whose two sides are tail. That is wrong. Okay? Always you should go with the random experiment of unbiased. Right? Unbiased experiment. Which is fair. That is also called a fair experiment. Fair. Fair experiment. Like honest. We cannot say that lie and we should not do that cheating. That is called fair. Okay, unbiased experiment will be taken. Are you clear now with this part? So this is introduction of probability. Okay, And probability cannot be negative, probability cannot be, 0 can be there, 1 can be there, between that equal likely event will come. And tomorrow we'll discuss the probability of finding the things, and then we'll go with applications, right? Okay, are you clear? Yes. Okay, thank you all.